When using the law of sines, there are sometimes when you are going to get two possible triangles rather than just one. And so this is an example of when that happens. When you are given two sides and a corresponding angle, it could happen. And in this case, it is going to happen, and we'll see why in a minute. What I always do when I put these on my triangle is I put my angle that is given in the lower left corner. So angle B is 38 degrees. And then of course, the corresponding side B is 8 is going to be right across from it. And I always put the other side that they give me in my upper left. So my C is going to be 10, which means the corresponding angle to that has to be labeled angle C. And we'll just label the last angle angle A, which means the last side that is corresponding to it has to be side A. So as we go through the law of sines, we are going to set up 8 over the sine of 38 equals 10 over the sine of C. When you do that cross multiplication, you of course are going to multiply the two that are diagonal of each other, so 10 times the sine of 38, and you'll divide by the last number, so 8, and that will give you the sine of angle C. When you divide that out, you will get 0.7696 approximately. So that equals sine C. When you know the ratio and you want to find the angle, you go second sine or inverse sine on your calculator. And at that point, we're going to round that angle to 50.3 degrees. We'll just use one decimal in our answers, which means over here on our diagram, that angle is 50.3 degrees. Well, if that's 50.3 degrees, then you're going to add 38 and 50 and subtract it from 180 to get your last angle. So angle A will be 180 minus whatever 38 plus 50.3 is. And you get 91.7 degrees. So this angle A at the top is 91.7 degrees. Okay, and if we use the law of sines to find side A, well, side A is across from that 91.7. So sine 91.7 equals, we were given 8 was across from the 38, so I'm just going to go back to that one, 8 over the sine of 38. And when we multiply the 8 times the sine of 91.7 and divide by the sine of 38, we get A is 12.98. So those are the first solutions to our problem. Okay? But in this case, you could swing this side. The 8 could be over there, which means that this base angle of your isosceles triangle is also 50.3, which means your C prime, your new triangle, the obtuse one, C prime, A prime, B, that this obtuse angle is going to be 100 minus 50.3. So I'm going to switch my colors here so you keep track of which triangle is which. So C prime is going to be 180 minus that 50.3 degrees, which is 129.7 degrees. Okay, we're talking this small triangle here. You always are going to subtract the first angle you get from 180 to get this new obtuse angle. In this case, it's C prime. And then we're going to go through the same steps as what we did to find the other sides and angles. So angle A prime is now going to be 180 minus, last time we did 38 plus 50.3. Well, this time we're doing the 38 plus the 129.7. So we get 12.3 degrees. So in this obtuse angle, if that's 129.7, and this over here is 38 because that was given, then our new angle A is going to be 12.3 degrees. Okay, well, we were also given that the side across from 38 degrees was 8, and we're now looking for little a prime. So we're going back to the same ratio as what we did before for little a, but little a prime is going to be over the sine of 12.3 degrees now, because that's the angle corresponding to it. And I'm going back to the original. I'm still doing the 8 over the sine 38, so that didn't change at all. I cross multiply, and a prime now is 2.8 approximately. So I'm going to have an a prime, an angle a prime, an angle c prime for the small triangle. And then for the large triangle, we had side A, which you could say is about 13 if you'd like to round that, and angle A and angle C. That is how you do the law of sines when there are two sets of answers.